When I'm trying to go from rectangular to polar coordinates, I always start with the picture, not the formula, because the formulas alone don't help me know, once I've made a choice for which r to use, what theta to choose, etc., etc. I have to make sure that my choices are compatible. So, -2, -2 root 3. Root 3 is about 1.7, so that's going to be in between -3 and -4. Not that it needs to be perfectly drawn, but there we have our point. Okay, so if I look at this triangle here, so essentially alpha would be the reference angle for any angle that lands me in quadrant 3. And I always start by finding r positive and theta in the quadrant where the point is. So alpha isn't the angle that I want, but it's going to be my reference angle. Okay? I think the simplest choice of theta in this case would be to choose this positive angle, so that theta would just be pi plus alpha. All right, let's take a look then at our triangle. So we came to the left, I'm just going to recopy it over here. We came to the left 2 and down 2 root 3. Okay, so those are the legs that we have here. Here I've labeled it with the actual side lengths, not the signed sides, because I've got my picture. I know I'm in quadrant 3. Okay, so I want to find my r, which will just be the hypotenuse of this right triangle. So 2 squared plus 2 root 3 squared is r squared. That's going to be 4 plus the 2 squared gives me a 4. Root 3 squared gives me a 3. 4 times 3 would be 12, and that's going to equal r squared. 12 plus 4 is 16, is equal to r squared. So if I'm choosing r to be positive, now that's a choice I'm going to make, it's going to be the positive square root of 16, which would be 4. Okay. All right. Now, I said if I'm choosing r positive, I'm choosing theta to be here. So let's figure out what our reference angle alpha is right here. And I could find that a couple of ways at this point. I'm going to go ahead and use the given information. I can see that tangent of alpha, let me write this over here, tangent of alpha would be opposite over adjacent. That's going to be 2 root 3 over 2, which is just root 3. That's making me think 30, 60, 90 triangle. 1, 2, root 3. The acute angle that has a tangent of root 3 is 60 degrees. That would be pi over 3. So alpha is pi over 3. Pi plus pi over 3. That's 3 pi over 3 plus pi over 3. That's going to be 4 pi over 3. Okay, so with that choice, I was choosing a positive r and a positive theta. So we've got r being positive at 4 and theta being, what did I just say, 4 pi over 3. Okay, then we were asked to find 3 additional names for our point. If I want to keep r positive, it's going to stay at 4. Now I want theta to be negative. So instead of landing in quadrant 3 by rotating around this way, now instead I'm going to rotate clockwise, like so. So now this angle would be pi minus my reference angle, negative pi minus the reference angle. That's the amount that I'm rotating. So that's going to be negative pi minus pi over 3. Okay. Notice it's the opposite of this whole thing, pi minus pi over 3. This would be rotating pi in the negative direction. I'm not rotating quite that far. I'm going to subtract the pi over 3 to get the amount of rotation and then attach a negative in front of that whole thing. Okay, so that's going to be negative 2 pi over 3. Excellent. So let me label that. All right, the other 2 points, I asked us to use a negative r value. So that's going to have to be -4 for both of them, because I have only 2 options for r. Okay? But let's draw another picture here for this one. So now what I'm going to have is, if I want to get to this point down here, but I want that to be the negative direction, so my theta's got to be landing in quadrant 1, not quadrant 3. It's got to be in the diagonally opposite quadrant. And let's see what I know. We had determined that this acute angle here was pi over 3, so that's going to be this acute angle here as well. Okay. So if I'm choosing r to be -4, I've just got to choose an angle that lands me in quadrant 1. Pi over 3 does it. So if I want an example with a positive angle, I'm just going to go with pi over 3. Now if I want a negative angle, I want something that's coterminal with this, but negative. So I'm going to take pi over 3 minus 2 pi. So that's pi over 3 minus 6 pi over 3, and that would be -5 pi over 3. All right, so these aren't the only possible answers, because of course there are infinitely many values that we could have for theta. But essentially, if we were going with r being positive, we needed to have an angle that was coterminal with this simplest one we found, 4 pi over 3. And if we were going with r being negative, we needed to have an angle that was coterminal with this, the simplest choice for that, which was pi over 3.